And I'm live. That is cool. Today is 9th of September 2025, Tuesday. And today we are going to study about policy-based data structures. That is cool. I don't know. I don't know what that means. They are just some extra things which have been provided to us by GCC, and they are not a part of the standard C++ library, the standard C++ specification. And there was this question. The first question itself at 1500 rating, which in this question we needed a data structure with some very curious properties. And these are the things. We needed a data structure in which we want our data structure to be sorted, right? We want our data structure to be sorted. Second of all, we want fast insertion. Fast insertion. That is what we wanted in that question. And another thing, we want random access, which means that given a index, let's say since our data structure is sorted, we want it to be sorted. We want fast insertion and random access. Sorted just means if I have numbers 1, 2, 3, 4 in my data structure, they appear in sorted order. So that, yeah, they appear in sorted order. And whenever I add some new number, let's say I also have in this 9 and 10, and whenever I add a new number, the insertion is fast. And by fast, I mean log n, LGN, log n. So we want the insertion to take at max in worst case log n, and we want random access so that since our data structure is sorted, I can say give me the fifth largest element in the data structure, and I would get this thing. And to get to the fifth largest element, I want random access. I want to get to the fifth element directly and not going through to the smallest element and then seeing what the next bigger element is, then the next bigger element, and then the next bigger element. That is bad. That is not what we want. We want random access so that I can see directly what the biggest element is right now, what the fifth biggest element is. These are the things that we wanted. And if we go, if we see what C++ provides among these things in the standard implementation. Wait a minute. Before that, I messed up a little bit. Yep, I gotta stop my recording here. Yeah, cool. So these are the things that we want, and among these things, we have two candidates which are really good. We have set, basic set in C++, standard implementation, and we have a vector. In the set, we have our set is sorted. If we are taking the ordered set, it is sorted by default, and it also has fast insertion. And by fast insertion, we mean log n time. So set has two of these things, but set does not give us random access. When we get a iterator from a set, we cannot just do iterator plus 5 to get to the element that comes 5 after this current element. We cannot do that in set. We cannot do that. The only way to increase or decrement iterator in set is using post increment or post decrement operators, or pre-increment or pre-decrement. So we only get two things in a set. In a vector, we do get random access, and we can say that our vector is sorted. But to keep our vector sorted after insertion is very slow, because let's say you have a vector like 1, 2, 3, 4, 5, And you can see right now the vector at the start is initially sorted, and then you added the element 0 into your vector, and let's say you add it at the end of the vector. Now you call the sort function on your vector, and since this number 0 has to come at the end, at the start, therefore this one will shift to the right to make space for this 0, this 2 will shift to the right to make space for this 1, this 3 will shift right, 4 will shift right, and 5 will take 0's original place. And the time complexity here is n. Time complexity is n, which is very bad. We do not want that. We want something like log of n. So we need a data structure which has both of these things, all of these things. It is sorted, insertion is fast, and we have random access. And then we asked ChatGPT, is there some data structure which has all of these properties? And ChatGPT said, there is actually, but that is not a part of the C++ standard implementation. That is if you go and look at the files or the specification for C++, that is when someone is writing a compiler for C++, the specifications are the things that the compiler must have for it to be considered a C++ compiler. But those are the like bare minimum things that the compiler must have, and that includes vector vectors and integers and all the things that C++ provides. So GCC and Clang both have implemented this standard completely. But beside that standard, they have GCC, I don't know about Clang, but GCC provides some extra things which are in a directory called ext, and we can actually go there. Since I have GCC and homebrew seller GCC 15, yep. This folder, if we go to include, which has all the files that are included, C++ 15, there is this folder extra. These are extra files. These are the files which have been provided by GCC specifically on it. Like these are the extra files, and I think we should have vector here. Yep. Everything else is just here. And from this point to all these files till the bottom, there are 120 of these. These are part of the standard, but I think these things are extra. These are not provided by GCC. These are not specified by C++ standard, and therefore this thing bits dot std C++ thing is only given to you by GCC. It is not a part of the standard. That is why you do not get this file with Clang. And there is this file also, extra or extended, and inside this file we have PBDS, policy based data structures, which has the things that we want to read about today. And in this question, which required a data structure with these properties, if you go to the solution, or like the one that I submitted, how much of data structure topics we should know before starting CP31 from 800 rating? I didn't know anything. I just started solving questions. So you can just begin, no problem. And whenever you see a data structure that you do not know about, you can just go and read about it. That is the best thing, right? And hello, like I am having started to learn backtracking, recursion, binary tree, segment trees. Shit, I do not know what segment trees are. All right, and I am able to solve 1500 rated, not able to, but I solved all the 1400 rated questions. in CP31, and I do not know what segment trees are. So you do not have to know everything before you begin. You can learn them as you go. So after these, I will deep into CP31 sheet. Please give some review. Yes, you can just begin solving questions. Yes, question grind. Yes, that is the thing. Hello. And yep, this is the thing that I submitted for that question. And this included these two things. And I did submit this yesterday on a stream. And when I was submitting this, I didn't know what this means and what is this. So now in today's stream, we are going to read about this. But yes, but when I was submitting this, I knew that how to use this data structure. Here I initialized this data structure. I first of all aliased typedef this thing to be called ordered set, and then I initialized a instance of that data structure, and to insert something to this we just call st.insert, and to get an order of a key. Order means in this st data structure how many keys, how many values are smaller than this, and strictly smaller, not even equal to or smaller, strictly smaller than this. That is the order function, order method. And yeah, that was cool. But today we are going to read about all of these. I saw two articles on PBDS, policy based data structure policy. One was this one, which is competitive programming specific, and one was on Medium, this one, which is like a general version of what policy based data structures are, written by this guy. 4-minute read. We can clap again multiple times. That is cool. And yeah, so first of all, we will read this one, and there are also memes, and then we can go into how it is useful in competitive programming. So that would be cool. But before we even begin, I would like us to have a common ground. In my mind, let me show you what I have in my mind. Yep. But before seeing the editorial, if you remember on the first day that we were trying to solve that question, I asked ChatGPT if there is a data structure which has these three specifications, and ChatGPT said you can use this data structure, and I thought ChatGPT is giving me something that is not a part of competitive programming, that is like very niche thing and people do not use this. But when I looked at the editorial, this was the exact thing that they were doing. So okay, yep. And in my mind there is the C++ standard, and this standard has core language features. Core language features, that is one thing that this standard has. And core language features include things like integers, how you handle pointers, what are different things, and everything like that. And then there is the STD standard library. And standard library is a set of functions or methods or aliases that should be shipped with the compiler. And this includes things like vectors, vectors, array, set, multiset, and yeah, pointers, mutex implementations, and what else? Yep, stuff like that. Bit set. These are the things that need to be in a compiler. And we have, in like generally speaking, two big compilers, GCC and Clang. Now, GCC is written by a open source community called GNU, GNU. And I would like you to look up what is the full form of GNU. GCC's full form is GNU C compiler. And if you look up GNU's full form, it is amazing recursive full form, one of the best full forms I have ever seen. And then we have Clang. Clang is by LLVM. So there are two compilers, and this is the specification that they are implementing. So these things are present in both of them, GCC and in Clang. But on top of these things, GCC, being a badass that it is, it provides some extra things like the bits std++ library that we use in competitive programming, and also the policy-based data structures that we are going to read about today. So yeah, that is the thing. We are just going to read about a subset of extra things that are provided to us by GCC. That is going to be it. And now with that, I have a question. Why do we call them policy-based data structures? Contest was fine. I mean, look at this. Yesterday contest. It is unrated, by the way, because question number D, there was some mistake in the problem statement for question number D. Therefore, they made the contest unrated for everyone. So no one's rating is going to change. Binary search, DP, number theory, bit mask combinatoring, these are mostly in these rated problems. Binary search. Binary search, I think if you can get good at binary search, it is pretty cool, pretty cool. And if you want to get good at binary search, I would recommend this. In here, go to navigation, binary exponentiation, where is binary search, numerical methods, there is binary search, and this is what I read, and this is cool. And the way that they implement it is different from most of the things, but this is cool. This is the implementation that I use whenever I want to use binary search. So that is cool. I solved only 3 and tried 4 but was unable to. I can tell you, I was also solving 3. And first of all, let me show you about yesterday. Today is also a contest. That is cool. In yesterday's contest, I solved 3 questions during the contest, but I messed up totally. My rank is 7,000. Uh, this is very slow. So look at this. I solved the first question in 3 minutes, the second in 14 minutes, and then the third in 2 hours and 3 minutes. And where can I see the submissions? I want to show you the submissions. And this was very bad. There was a little bug. Tmux attach on test. This is my solution for the third one. And look at this. I did the first one. Contest began at 05. So this one was 3 minutes after the contest began. This one was 14 minutes after, and 21:34. This one was 1 hour and 29 minutes after the contest began. And this one was wrong. There was some mistake in my implementation. Then I submitted this again after some time. Again, something was wrong. And then I got it right and I submitted it. What was the thing that was wrong? You might ask. Here, in this, we take in k. K is supposed to be power of 2. And when I'm calling my recursive function, in this I'm left shifting 1 by k times. But 1 here is an integer and k can be at maximum 60. So when you left shift an integer by 60 times, more than 32 times, then that integer is going to become 0 and that is wrong. And when I got it right, all I had to do was make this one a long. That was the only mistake. Shit, that is bad. That is bad. These problems need more than just knowing basic binary search. I also tried a lot to debug, but was not able to do. Yep. And in the editorial, this is it uses backtracking, and yep, they need something more than basic binary search, but they also need basic binary search. And if you cannot even do basic binary search questions, do not expect yourself to do hard questions. This one used backtracking, and this one was fine. There were only a few conditions that I had to see, and then it worked. I guess it just needs more experience to solve them. And now back to the thing, policy-based data structures. Now, GCC, like PBDS, policy-based data structures. Why are they called policy-based data structures? When people say policy-based data structures in the context of GCC, they are referring to an extension library. Extension library, as we can see, it is extension. In the include section, this one, ext, extension. They are referring to an extension library in GNU's C++ STL implementation. This one. Oh shit. Not just everything in this. So when they say PBDS, they are not referring to all of these things in this policy-based data structure. They are specifically referring to this one, associative container. And these are the things in this associative container. It is 861 lines long. These are all the things in the associative container. Copyright, it has a copyright. That is crazy. Copyright on free software. Okay. Copyright by Free Software Foundation. They are referring to this one specifically. This library provides additional data structures like tree, an order statistic tree, essentially a balanced BST, binary search tree, with extra abilities like finding the kth element and the rank of an element. Priority queue variants has tables with tunable properties. Okay, these are the things that are provided by this library. And then template and order statistic tree. Okay, that is what we read that. Now, why the name policy based? Because you can control their behavior using policies. Okay, function objects, functors. Functors. You know, if you do not know about functors, if you do not know about functors, can go to posts And I did make a post about functors, if I can just find it at some point. Yep, this one, functors, functors, functions or structures which only have this operator, this parentheses operators, they are called functors, and that is cool. And they can also have a state. In this case, they have a state. This functor was called with y, and we had a functor multiset mul state, and that uses internal state to do something that we want it to do. So they are cool. 8-second or higher data bit data type. Debug. Yep. Yeah, I mean, you cannot solve these just by searching how to do binary search and just reading the algorithm. And you cannot, I mean, I'm not saying that this is enough. I'm saying this is necessary to get there. Yep. And yeah, because you can control their behavior using policies, function, objects, functors, or templates that dictate how the data structure works. That makes sense. That makes a lot of sense. If I want my data structure to behave in some certain way, I can change it using policies. So the specifications here are called policies. That makes sense. Or like there are strange things in C++, and this is one of them. These are called policies. Okay, instead of being rigid, the data structures are parameterized by these policies. Okay, so for example, what I think this means is uh, policy.cpp. Let's say we have a vector like this, and generally we have some control over our data structure. Vector is the basic data structure that has been provided to us by the C++ implementation library, and we have control over it. And we can say we want to store an integer inside this data structure, and that is the control that we have. And this is not a lot of control, but this is still some control. And when we use something like sort, v dot begin or v dot and v dot end, we can give it our own lambda function here, int I, int j, and return something like I lower than j to sort it in ascending order, and I greater than j to sort it in descending order. So that is the amount of freedom that C++ generally gives us. And we can say here int is also a policy, and here giving to the sort function the beginning iterator and the ending iterator, and then a comparator function which will be called by the sort function to compare how two given elements are related to each other. So that, I think we can also call that a policy. So that is the normal amount of freedom that is provided to us, but that is not enough in some cases. In some cases, we want more control. So we can specify what the key is going to be, what the map type, the comparison function, tag, what should be the underlying data structure, use a red black tree inside. And yeah, we can give it a lot of new things. That is cool. Okay, so policy-based data structure give us a lot of freedom onto how we want our data structures to behave. See those template parameters, the policies are comparator function, comparison policy, how keys are ordered. And also let's see this thing. This is how we initialized our data structure. And you might also ask, why am I not seeing any errors? Because there is no LSP running, no active clients. I turned off the LSP, therefore I'm not getting any errors here. So I guess we can compare this with what ChatGPT told us. That is the basic template, and inside this, and yep, so key class tree, that was tree, and okay, so this is the tree that we are invoking here, right here, tree. And in this tree, this is the template that it needs. Okay, it needs to have a key, and the key that we have provided is integer, which is telling the data structure that we are going to store integers. And then mapped that we have provided is null. Okay, I guess because we do not want our data structure to be associative. And then we are providing the comparator function, which is here less, which is here also, it is less. And then we need a tag, and for tag we are saying use the red black tree implementation. Okay, and then here, what is this part? Yep, this part is node update. How do you update a node? In this, we suffice just by giving this one thing, tree order statistics mode node update. Okay, that must be something. And this whole type, we are calling this ordered set, and that is what we are using. So just look at the sheer freedom that we have. We can say the type of key that we are going to store. We can say how it is going to be mapped. Then we can also provide a comparison function. Then we can tell which data structure to use internally, classic node. And then we can say this thing, which I do not understand what this thing means. And then what is the allocator? The default allocator is character. Okay, and allocators are used to give new space from the free store or from any place to a data structure to be stored. And I do not completely understand allocators, but that is their basic function that I know about. Okay, that is cool. That is cool. This is the amount of freedom that we have with these data structures, and they are called policy based because we can control their behavior through specifications, which we are calling policies. Okay, memory allocation policy, node update, that is what we do not get. Comparison function, comparison policy, tag, which balancing algorithm to use. Splay tree tag, okay, we also have splay tree, which is something, and then red black trees. Node update, a policy that decides what extra information each node maintain, like subtree size for order statistics. That makes sense. Hello. So, should I complete sheet easy to medium and then do whole sheet hard and mastering the topic? So solving tagged questions, or should I do tagged questions side by side after doing end topic? By tagged question, you mean questions of a specific type? Should I completely complete sheet easy to medium? Okay, completing the sheet is not the goal. The goal is to get to know things. Right now, right now, here I have only solved 5 questions at this level, but that is not making me sad because I know I am learning new things here. about policy-based data structures. So, uh, solving the sheet and learning side by side is the recommended best thing you could do, and then do the whole sheet hard and mastering. I mean, you cannot just take a sheet and start solving it. You will need new things. You will need to study new things, and yeah, that is the natural thing to do. Just solve questions, and whenever you see something that you do not know about, then go and read about it and start solving the questions again. That is cool. How long it took you to come to this level? And for competitive, well, the level is not that great, but in competitive programming, this is my 72nd stream, 73rd stream, I think. And yeah, I guess 3 months in competitive programming. But before starting competitive programming, I've done other things also. I did assembly language, and I can still write assembly language, which is cool. Assembly languages, assembly language is very good. It's very good because it gives you a lot of knowledge about how things are happening under the hood. And so when someone says, so whenever I see some low level things in when I'm in relation to when I'm reading about some C++ things, I can understand them because I have done assembly language. That was one of the best things that I have done relating to programming in general. Assembly language is pretty cool. And for programming in general, I have been programming on and off for since this morning, on and off for at max 2 years at this point, because I'm in my second year, third year right now after school. And yep, by swapping out these policies, the same the same base data structure can behave differently. For instance, use red black tree for red black tree, or splay for s split trees or something. I wonder if they are in this book. Splay, nope, they are not. Use order statistics node update as the node update policy to make the tree order statistics. To make the tree support order statistics. Order and order. What do they mean by order? By order, they mean the order of a particular element in the set. And what is order? Shit, I feel like I've read about this something. In in of a what is the order of a number in a set? Word order is slippery because it means different things in different mathematical contexts. Order in group theory. Let me give you the main issues, the main things. If you are talking about a group, a set with an operation, that is a group in mathematics. A set with an operation, a set with an operation like where I can add things. The order of an element is the smallest positive integer such that integer such that integer k such that ak ak a is the element whose order I want. K, wait, is the smallest positive integer k such that a power k. So k is going to be the order of a, and e is the identity of the group. Okay, so here are three things: a, k, and e. If no such key k exists, then the element has infinite order. Okay, power. If e power So isn't this just log? If we have a equals e, if we take natural log on both sides. So here we would have k ln a equals 1. So k equals 1 upon ln a. And wait, when login is bottom, I think that there is something that we can do. Ln e divided by ln a. There is something that we can do. Wait, isn't this just subtraction? Ah, shit, I do not remember the log formula. We can do something with this, right? When the log is in division, there is an identity like this. When I want to find log of, let's say, a base a with b, it is equal to log c b divided by log c a. And here we have log with base e. Base is the same in both the cases, so we can write it as ln log base a to reach e. Yeah, k equals this log base a log base a to reach e. Okay, but we do not have a general formula for this. We can have a general formula for this though. Okay, that is what order means in group theory. Example, in the group of integers modulo 7 under addition. What is that? Group of integers. Makes sense. Integers 1, 2, 3, or 5, even negative numbers, -1, -2. Modulo 7 under addition. Modulus 7, take their modulus with 7. The number 3 has order 7 divided by GCD of this 7. Since adding 7, adding 3 7 times gives 0. I guess. Okay, we can skip on group theory, but we can. This is what we need. Order of a set. This just means the number of elements in the set, its cardinality. Ah, that makes sense. That makes sense. That I read about this in college. The order of a set is the number of elements there are in the set. Order in ordered sets. Ordered set. Yes, that is what we create, right? Ordered set. Here, ordered set. Order in ordered set. That is what we need. If the set has an ordering relation, this thing, less than or less than equal to, the order usually means the arrangement or positions of elements according to that relation. Example, in the ordered set of natural numbers, the order is usually 1. Order in number theory, okay, we do not need all that mathematical things. You want me to this order of key, since it's a practical computer science usage of order of numbers in a set. No. Yep, so what do we know that we didn't know before reading this? We know that policy-based data structures are data structures whose behavior we can change using policies. And these are the degrees of freedom that this policy-based data structure provides. It is called a tree. And in this, we can tell it which type of key we want, what is going to be mapped, and that must mean how. And by mapped, they might mean something like when we are using a map in C, which type is the value going to be. Since in our question, we don't have value, we only have the key. So we have this equal to null type also. And then the comparison function, the tag, the tree that we are going to use. And this is for something. This is to tell the data structure what additional information do we need other than the key and the value in our node, which we can use to figure out things. And in our example, in our implementation, we use this thing, tree order statistics node update, which tells the data structure to make this set, this data structure ordered, so that we can calculate its order later. And order of a set is how many numbers are smaller than this given key in the set. Okay, we can now move on to reading this Medium article. Yo, hello. Eric, you said I should use GNU, and we are using now GNU, GCC, but there is a problem. You are learning C++ in old school way, I guess. Yep, I am learning C++ old school, I guess. I want to ask, do you use Clang LSP while you are doing that? I'm learning bit manipulation. Bit manipulation is cool. It feels magical. And if you do in bit manipulation, let's say you have some binary number like this, x, let's call this x, and if you do x minus 1, take its and with x, and if this thing equals 0, then you know for sure that x is some power of 2, 2 power k, for for some integer k. And that is crazy, because when you subtract 1 from a power of 2, you get 1, 1, 1, 1, and this would become 0. And when you take AND of this new number with the original number, you will get 0. And if it is equal to 0, what you get, then it must be a power of 2. Bit manipulation is crazy. And now we are going to read this article, whatever it is. Here we are going to talk about a data structure that will undoubtedly strengthen your armory of code, the policy-based data structure, or more affectionately, PBDS with the memes. Apart from the customary introduction and implementation, this article offers guidance for you to tinker with different flavors of PBDS as well. Let us dive in. Okay, what are policy-based data structures? Policy-based data structures in C++ are somewhat similar to sets. Mhm. They provide a few extra but considerably powerful operations which grant a programmer the virtues of high performance, semantic safety, and flexibility as compared to the standard data structures of C++ library. Okay, what are the things that it provides? High performance, okay, semantic safety, and flexibility. Three things which are listed here. Flexibility, we can see. We can literally see the amount of flexibility that is provided to us. We can tell which type of key we want, what is the comparison function, what should be the underlying data structure, what extra information should a node store, and yeah, this is part of the extra information, and what allocator we are going to use. I am not very sure about like the specifications of an allocator, but the other things, yeah, mapping and all that, I'm sure. Yep, the flexibility is crazy. We can see that. High performance, because this is by GCC, not some noob. This is by GCC, so it is high performance. This is written by people who write compilers, so this has to be high performance. And then semantic safety. So these two things, you can have flexibility of something on something that you wrote, but you are not guaranteed to have flexibility on something that you personally wrote. And semantic safety, that is the methods that we are going to use on this are similar to the methods of the standard library, and which we can actually see here. we used these methods, dot size and dot insert. The semantics are the same as an ordinary set or tree, so you do not mess up with the names, and I think that is what they mean by semantic safety. Headers for policy-based data structures. These are the headers, just 12 lines of headers. Cool. What are they? Bro, you in college? Yep, I am in college. There's a cool problem on Discord for PBH. Ah, which one? 2022 divisionals. Yeah. That one, the one you sent, in which we had the next, in which we had to find a array, in the problem in which we had to find a array A1, A2, AN, where A1 has to divide, AI has to divide AI plus 1. And there were some values. AI could be equal to any number from 1 to n. And we had to find the number of arrays, the possible number of arrays that could possibly be. Can we use? Okay, a new one. Okay. Till solving. Okay, it would be hard to just say. I've learned about DFS, BFS, basic graph things. Or should I? Yeah, you just start solving questions, and whenever you see something that you do not know about, then you read about it. And Eric, I would like to know, you use GCC for compiling, and when you write code, do you use some LSP? LSP, like some LSP, attached TCP. Like here, I'm using the Clang DLSP, which is giving me this error right now. This one, Clang DLSP, but this LSP is by Clang. So this LSP does not know about the GNU libraries. Like this one, this is a GCC library, GCC header, and this does not ship with Clang. So I had to go to the my LSP specification configuration, and here I had to say include these things externally, and this file right here, this file has the bits std file, which comes with GNU. So I had to tell the LSP specifically to include this, but for some things they are so GCC specific that Clang D cannot use them. So if I want to use policy-based data structure, I cannot use Clang D LSP with them. Or maybe this is because in Apple, Clang D is very finely tuned for the Apple hardware, and it is hard to make them compatible. GCC and Clang, it is very hard to make GCC and Clang D compatible with each other. So it does not work. So I've decided to not use Clang D. Won't be using a LSP. Okay, cool. And it is easy, from what I have seen, it is easier to use Clang D and GCC when you are on Intel hardware. But this is Mac hardware, and mm, since GCC has crazy things, GCC has a thing which is 128 integer, which does not come with Apple. So Clang D is not going to support this. So when I include some Clang D library like this one, like when I import some Clang D library like this library might under the hood use something crazy GCC specific, like 128-bit integer, which like is totally not supported by Apple. So I will get error. So I cannot use ClangD LSP. And now back to the article. Headers for policy-based data structures. Include the following header files in your code to use policy-based data structures. Include this and this. Namespace is going to be this. GNU PBDS. Yep. Okay. Namespace. They are these whatever things are here. They are defined in the GNU PBDS namespace. Templates. Defining templates when all elements are distinct. Okay. Before moving on, in this point, they are defined in the GNU PBDS namespace, and which we can actually check because I have GCC installed. Homebrew, GCC, this version, N include C++, external PBDS, we have associative container, and using namespace. See, we can literally see this. This thing has been defined in namespace GNU PBDS. And this guy is saying it is defined in GNU PBDS. So yeah, he's not lying, at least that is cool. Templates. Defining templates when all elements are distinct. Defining templates when all elements are distinct. Template class T using name given to data structure equal to tree T null. Okay, where is the tree defined? Tree is defined in the other thing. Policy tree. There is also try. I do not know about try. I will have to read up on that. But here we have tree. See, tree order statistics node update. Tree order statistics node update. Tree order statistics node update. We are seeing some things that is crazy. Okay, tree. I'm looking for this definition of this thing, tree, for the template of this thing. It should actually be, wait, it should be in the container, I guess. Using namespace GNU PBDS. Hash function, equation. Okay, this is not the one. It though it has things like this, tag and key, tree, try. Retreats, a tree-based container. I guess this is the one. Yes, we found it. We found it. This is the one. This is the one. The first thing is the key. Then we have mapped. Then we have the comparison function. Then we have the tag. Then we have this extra information which needs to be stored. And then we have the allocator. And the class, this class is named tree. We found the exact same thing that ChatGPT gave us. Class tree, and you can match all of this with this. This is the exact same thing. Okay, class. Shit. And this is not the this class is not a base class. This class is a child of this class. PBDS tree base. Tree base is the basic class. Okay. We can even look for the definition of this thing itself. Type def, this thing to base type. Here is the definition for this, the base type itself. That is very cool. No, shed. We looped back and we are back at the tree definition. Hmm, that is cool. That is good. And here is all the implementation. How do we, right now I'm at the start of the class definition. How do I go back, go to the other side where this bracket ends? There is a specific key in Vim. How to go to the opposite parentheses and Vim. Percent sign. I'm here and I can press percent and I'm at the opposite side. This many. Oh, it just took 52 lines to not define it but declare it. Here is only the declaration. Look at this. There are only declarations. There is no definition for any of these. There is some definition, but not for all of them. Definitions come later. This is cool. This is cool that we can just look at the actual thing. That is very cool. Yep. Okay, your compiler is GCC, but when you write code in GCC, do you get stuff like this? When you write code, do you get like this? All of these suggestions in main int a equals some number 5, and then all of these suggestions, do you get them? And if you do get them, do you also get them for policy-based data structures when you are using policy-based data structures? And that would be interesting because I've seen good competitive programmers and they do not use LSP. In Erecto's stream, he does not use and he doesn't use an LSP. He just writes code. He doesn't have auto suggestions. The only thing he uses is this thing. When you create a opening parentheses, the closing one comes automatically. That is the only thing I've seen him use. And I think he doesn't even use that. Sign of a good competitive programmer. And from now, I have also decided I will not use any LSP. I will just write code on my own. Using namespace, GNU namespace, PBDS. Yes, we know, we have literally seen that it is GNU PBDS. Now templates. Defining templates when all elements are distinct. Template this using namespace, name given to structure. Aha, okay, equals tree of this type. Red black tree. Okay, yes, we can literally write these things without that what we were using earlier. Attach TCP. So if we do PBDS and in this line we can remove all occurrences of the word PBDS. How? By substituting GNU PBDS with literally nothing. And now this will still work. And we are saying type def this, or we could also say using ordered set equal to this thing. And hopefully this should still work, and it does. That is cool. And I have also changed the underlying compiler which assistant Vim uses here. Now it is using G++, which is GCC for C++, and 15 here means I want to use the GCC compiler which I manually installed and not the one that comes with Apple, because Apple's one is not very updated to the latest compiler. That's F greetings, not CPP. But one caveat is that whenever I enter a file, I will have to manually turn off my LSP using LSP stop command at the bottom here, and then enter. LSP is off. I'm not getting any errors, but I will also not get any suggestions. These are suggestions not by the LSP but by something else, which looks at text which is already present in the file, and this is not very smart though. And here, pretty sure I do, but I don't really pay attention to suggestion. Ah, sign of a good competitive programmer, I guess. Someone who is into ICPC, who solve, who gives ICPC contests. That is cool. And yep, template. Yep, we know how this works. I mean, what this is. In defining templates when duplicate elements are also used. Templates using namespace given headers.cpp. Defining template when all elements are distinct. Okay. And defining templates when duplicate elements are also used. What is the difference between the two? Okay, there is some difference. Less equal to less equal. Okay. Makes sense. Makes sense. You are only using the less operator, but here you are also using less than equal to operator when same elements will also be there in the set. Okay. A word of caution. You might get the following error while importing PVDS headers. Yep, this is in Windows. Fatal error. This thing, no such file or directory for Windows. Okay, Windows people use MIG-GW. What is actually MIG-GW? MIG-GW. MIN-GW. What is MIN-GW used for? MinGW is used to provide a collection of GCC compiler tools and other GNU development utilities for Windows. Minimum GNU Windows, allowing developers to build native Windows applications and libraries using the Windows API, often for C and C++. It is a port of GNU tools enabling, okay, since GNU is a set of tools, MIG-GW is a fork of GNU in that sense that all the tools are specified for Windows GW. Okay, if that is the case, then win if that is the case, then window people are in a sense not stealing, not specifically stealing, because GNU is open source. You can do whatever you want with GNU tools. But shit, you have a corporation, you can create or your own things. GNU tools on Windows. Minimalist GNU for Windows provides a port of GNU compiler collections, GCC. Shit, GCC does not mean GNU C compiler, it means GNU compiler connections, collections. Shit, okay, I didn't know that. I thought this is GNU C compiler. This is GNU compiler connection, collections, okay, and other GNU utilities to Windows operating system. Okay, that is enough for that. Going back to the article, you will find a file that looks something like this. Rename it to this. Heck, what the heck? What is this? 64 bits, and you are all set to go. Go to this directory and do this like this. Okay. Extra operations. So what is it that gives PBDS an edge over sets? There are means. There are two extra operations and keep in mind the things that we required our data structure to have. These are the three things. They have been messed up. Let me write them again. We want our data structure to be sorted, fast insertion, and random access. And instead of random access, we can also call it finding order. Random access is fine. Random access is fine. Shit. Random access is fine. These are the things that we want our data structure to have. Let's see, does PBDS provide us that or not? There are two extra operations in PBDS data structures apart from those in the standard library. Each of these operations has a time complexity O of log n, which is very cool. Order of key and find by order. Returns the number of elements is strictly smaller than k. Find by order returns the address of the element at kth index in the set using zero-based indexing. That is, the first element is at index 0, and that is all we ever wanted from life. Since our basic set already has a few things. A basic set is already sorted. That is cool. A basic set is already sorted, and it also has fast insertion, but it was lacking one thing. It was lacking, spoiler alert, random access. But now we have it, folks. For the longest time, this is what we didn't have in our basic set. Our basic set only had these two things, and it still has these two things. But if we use something called PB, PBDS, uh, PBDS first try, if we call this, use this, then we have everything. We have sorted, we have things in sorted order, we have fast insertion, and we also have random access. That is cool. And you might ask, how do these two extra operations give us random access? You can think of this find by order as if you were indexing an array, as if you were indexing a vector, where if you do find by order 0, you will get the smallest element, then find by order 1, you will get the next smallest element, and so on. So that is cool. That is basically a random access. And random access, not in the technical sense, because you do not have a base address to which you are adding some offset and directly going to that symbol, directly going to that address. Instead, your random access is a bit slow, and the slowness is simply log of 2n, log base 2n, which is not very slow, because let's say in random access, in genuine random access, you can just go to something and the time is constant. But in this, let's say you have quintillions of elements in your set, and if that is the case, at max you are going to go through 64 different nodes, because every time, and this is basically binary search, every time you are dividing the sample space into two at every decision. So 2 power 64 is more than quintillion, so that is like almost almost random access. So this is cool. We can get with PBDS, policy-based data structures, sorted, fast insertion, and random access. Cool. And these are the two operations that we need to care about. Order of key, this kth element. How many elements are smaller than this kth element? And find by order. What is the fifth largest element in our set? That's cool. STL set? No. PBDS? Yeah, cool. Now ordered set. Backtracking. I'm reading about, is it JS? Nope, it is C++. And if I'm learning about DP from the CLRS book, and backtracking, I read once about backtracking from the CPHB, and there were things other than backtracking like pruning. Right here we have backtracking for the queen game, how to place queens on a board legally, and then you can prune the search and basic things. But I haven't solved a lot of questions on this. I've only solved this one which they gave in the example. I have to read more on this. And yeah, ordered sets can be used as an extension, as an extended version of sets in policy-based data structure, for the data structure to accept distinct entries. For the data structure to accept distinct entries, template to be used is this. Distinct entries, like a set, not a multiset, but a set. Class name T. Okay, I think this guy is using this template prefix before this alias, so that, okay, we can also use this, and we can then remove this integer from here, and at the start we can say template type name T using this, and we have T there. But then when we are defining our data structure, like here, we would have to say int, and now this will work. Hopefully it does work. It compiles and it works. But if I now remove this part, so I think the reason for this, not that I think, the reason for this is that you can have this simple declaration and you can use this to store anything in your set. And all you have to do when you are declaring your set is tell here the data type, give here the data type that you want to store. You can now give here strings or anything long, and yeah, this would work for everything. But if you are not using this, you would have to say long, or whatever the type is right here. And those are the two things you can do, the two options. And shit, not just this, you would have to change long here also. Shit, that makes now it is making more sense. Now it is making more sense to use a template here. Template type name T. Here, replace this with a template and replace this with a template. And when you are defining the data structure, use int here. That is what I do. Okay, and compile runs. But if suppose the error comes when we were not using the template, and let's say you were using at some point integers to store in this thing, and then you decided to choose instead of integers a long. But when you used long here, you forgot to change integer to long here. And I think now there we should have compilation error or not. because integers can be converted into long. That makes sense. But if we do now, yep, integers can be converted into long. So it would work in this case. But if you were to change this to string, then this would give you error. You just even to compile, I think this should give you error. This is not giving you any errors. Why is it not giving any errors? This should be giving errors because we are using string here, but the comparator function is integer. Change this to a string, and here we use integers. I'm looking for, why am I not getting a compilation error? We should be getting compilation error. Let's provide a custom function, lambda function here, int a, int b, return a lower than b. Okay, compilation error because of this. Yep, now we are getting the compilation error, even though I do not want an error now. Type mismatch argument template list for templates key this. Where is the error? Ordered set was not declared in this scope. Expected got lambda. Okay, so we cannot give lambda functions there. Let's write a functor and use that. Struct come, and yeah, it will have just, it will return a boolean value and operator. This one, it takes in integer a, integer b, and return a less than b. That is the only thing there. And here we will give that function, and it is compiling. And if we were to bring back the whole code, I less than n I plus plus, in total long response is 0 response plus equals st dot size minus st dot order of key, the current key. When we don't need this, we can directly use auto ij in st in v. Order how many things are smaller than the current starting key. Starting key is j. Update the response and sp dot insert j. Order of key, key of order. What is the actual function? Shit, I messed up a little bit. What is the interface? Order of key. Size. st dot size. Order of key. That is what I'm using. Order of key. ORDER. OFKEY and adding it to the response. What is the error? This is unreadable. This is unreadable. Okay, the operator is not working correctly. The operator is not working correctly. So if I change the operator to the basic less, now it is working, but why wasn't my operator working? Class, let's define a class CMP, which will have this and public, a single operator in I and j. It will take in two integers and return I lower than j. And I think we need this at the end of the class. Provide this operator. Not working. It is not working. Yo, how are you? How are you? And shit, it is not even 3 o'clock there in the morning. So pretty early, very early. And my custom operator is not working due to some reason. My functor is not working. Why, why is this not working? This should be working. If I provide the same functor to this CMP, and let's say we remove all of this thing. Okay. Wait, expression is broken. Okay. Okay. So we have to provide not just the class, but a instance of the class. Hmm. Okay. That is certainly wrong. Let me start my LSP for now. And remove this, remove this, remove this. Comp doesn't refer to a value. I guess using the new operator before this. Now I am giving it a functor. Or maybe not. Shit. What is the mistake? What is wrong? What is wrong? What is wrong? If I were to define something like auto CMP equals a lambda function which takes in two integers I and j and then return I less than j and provide that thing. But instead, if I were to write this thing here directly, I less than j, still it is not working. Because that vector is a vector of pairs. That makes sense. Sunday I'll be traveling to Japan. Of course, you should be excited. Said you are traveling to Japan. That is very cool. From Texas to Japan. Japan. There, there you can see nice things. Boku no chinchin chisai desu. Say that to someone. And okay, let's get back to our policy-based data structure thing instead of writing our own comparison function. Turn off the LSP. Yep. Using this equals to this and sort. After sort, ordered set SP and for auto I j n v long rest equals 0. Rest plus equals rest plus equals something which is st dot size minus st dot order of key for j and st dot insert j, and at the end see out that response. Yep, that sounds about. Nope, nope, that is wrong. That is wrong because we have our own comparison function. Now this is the standard comparison function, but still it does not work because we have given our own comparison function, stupid comparison function here. Now there's one. That is fine. You have to mention the specific function name after mentioning the class name. I mean, like class dot function name. That's how I know. This is different because the function name. I have to meet someone in Japan. It's been long. Okay, it's very special. My dad will be going with me, which is a bit restriction. Lol. Okay, I wish I could travel solo outside of states. All of that is even crazier due to the fact that you are just in 11th standard. All of that is making this thing even more crazier. It's been so long. I have to meet someone. Those are some tough words, dramatic words. It's been so long. Yeah, the thing that you were saying, class, come here, public, bool, operator. This operator is going to take int I and int j, return I lower than j. Here, this thing, operator, this is not the name of the function, but it says that, let's say I have an object of this class, let's call it C equals new CMP. And when I do this thing, C1, comma 2, I will get true whenever I do call these parentheses on this object. This function will be called this one. So I'm just overriding the operator itself, and that is just crazy configuration freedom that C++ provides. A GF from Japan. She has been studying in States till standard 10. After she moved to Japan for higher studies. I generally directed using lambda function instead. Those are very conflicting statements, but okay. Yeah, lambda functions are great and okay, good for you. Good for you. That is so crazy. Good for you. I'm happy for you. And let's study a bit. We haven't even finished half of this article. And after this, we have this one, which is competitive programming specific on policy-based data structure by Mr. Adamant. So we have to read it adamantly. And nice for you. Good for you. Here, elucidating the extra operations offered by PVDS. Let A be an ordered set in which the elements these are inserted. then elements in the ordered set A would be stored in the following order. Okay, and find by order. Here, find by order will return the address of x plus 1th element, because this is zero based element in the ordered set. For example, find by order 3 will return 5, the address of 5 as the fourth element, I guess a pointer to that element present in the set 5. Okay, order of key. I turn this off. Okay, now it is beautiful. Cool. Order of key. Here, order of key x will return the number of elements strictly less than x. Yep, number of elements which are strictly less than x. For example, order of 10 will return 5 because there are 5 elements that are smaller than 10, as well as entries, yeah, as all the entries that are less than 5, that are less than 10. Here, using namespace std gnu pbds, using template, this thing, insert all of this and then find. Okay, this, since this returns a pointer, we have to go to that place using the dereference operator, and we will get 5, and this thing returns the number of elements that are small. That seems to be enough food for our gray matter, but Idil Mangamur meme. So moving ahead, for the data structure to accept duplicate entries as well, we shall define a multiset. The template to be used for is this. The only thing that is different is less than equal. So when we have less than equal, it is, we are creating a multiset. That is cool. Okay, implementation, and we would have to see why less than equal to works and gives us a multiset. Appreciate that. Lol, my dad knows, but I never dare tell him now. Okay, that is generally a bit reversed, but that is why I'm just taking my dad, to be honest. Shit, and he is taking you there. That is very cool. And yep, less than equal to all of that, and the implementation. Yep, we would have to see how this function is called internally. This comparator function is called internally to make things done, and we can literally see that, like quite literally. If we go to the include things, ah, shit, extended libraries, PBDS, policy based data structure, and in there, turn off the LSP. It is turned off. Free there. Yep. Here is the declaration for the data type class named tree, which is a child of this class. PBDS tree base. This is the base class. That is why it has base in the name. And these are all the things that we have to give it. Key, mapped, comparison function, tag, template, some things, and then our default allocator, which is char, character by default. Okay, and now we can have this. So first we added 1, then we added 10, 10, 10, 10, and then 7 and 5. So internally we should have 1, 5, 7, and then 4 tens. So find by order 2, we should get 10. We should get 7, yep, because at 0th place we have 1, then we have 5, then we have 7. And then find by order 5, we get 10. Order of key 10 is 3, and order of key 11 is 7, because we have all of these extra tens inside. That is cool. I asked my dad a long time ago. It's been long since we met, and he said that is when he gets time, he will take. I share everything with him. That is cool. That is cool. That is cool that you can do that. And yep, study. implementing a data structure, but the fact that you're just in your 11th standard, that is a bit astonishing, to be honest, TBH. And yeah, for this implementation, we will use T type equals to pair of integers. That is cool. In other words, it is an ordered set of pairs. Here is the implementation of an ordered set with distinct elements using pairs. Okay, use this and the basic definition. Distinct. So this is a set. This is not a multi-set. We can actually write two things. Tmarks attach TCP, and here using ordered set equals to this, using ordered multi-set equals tree of and we should also use template type name T instead of saying specifically integer here. And tree, and again the same definition would be here, but you would call it a multi-set, and here we would have less than equal. And when we run and compile, hopefully it works, or maybe it doesn't. Shit. Yes, it doesn't, because we have to say integer here. Now it does compile. That is good. And we could even use multi-set here. It wouldn't matter. Yep, it doesn't matter. That is cool. Here is an implementation of an ordered set with duplicate elements using pairs. Okay, we can use pairs. That is cool. Okay, just like a basic set. Customizing the name of the data structure. Name to be given. Just replace the name to be given in the template with the name you want to give to it. Power is yours. Power is now yours. Use it carefully. Yoda. For example, if you want to name your data structure Anish, then the template should look like this. Okay, I would not want my data structure to be called that. And that was it. That was the whole article. Everything else is just comments. Nice. Okay, we have that. I'm finished. Yep. Okay, further resources, questions, the end. Okay, and now we can move on to this competitive programming specific. Said that to be open to him for everything because he was also like me during childhood, but he wasn't able to share everything, and therefore he kept everything to him, and it may lead to depression. Did you go through um before Mersenne, random number generators, RNG? Yes, that is very cool. Not cool, that is very good. That is very nice of him. That is actually very nice of him. And okay, let's move on to this. Did you go through Mersenne 1? Yep. I didn't see specifically what Mersenne number generator does, but I saw some things about random number generators in general, that they need some seed, and they use that seed, and they use a formula like this. They have some seed, a prime number, that's P plus C. They use some formula like this, where P is a big prime number, which is the seed, and every time that they want to generate a random number, they increase this number by something, and they also have a modulus with some other prime number. This is the formula, but I don't know if this is the one that is used for Mercedes one. and they call these functions random number generators. Yeah, that is all I know, but I would have to look at this like with more detail. And that is cool because if you think about it, random numbers, you want your computer to give you random numbers, and for that you have to give it a algorithm. So you are telling your computer, give me random numbers, and you are telling your computer, give me a number, and your computer says, which number? Any number. Which number? Any number. Does not make sense because your computer does specifically what you tell it to do. So this is what you do. Just a fixed algorithm to find random numbers. That is cool. And there are also more complex random number generators which read weather patterns and create numbers on the basis of that random weather pattern. Those are crazy. And now on to this thing, policy-based data structures for competitive programming. And there is also a contest today. Hi everyone, hello. After a relatively long lull, I decided that my contribution grown too slowly. The hour has come to please you with another article in the blog. Okay, 2 months ago, user Perlik wrote an article in which he described a very interesting stale implemented data structure that allows you to quickly perform various operations with substrings. Some time after I tested it on various tasks and unfortunately tend to get a negative result. Rope was too slow. Instead, when it came to working with individual elements, he he is referring to some data structure. For some time, I forgot about that article. Increasingly, however, I was faced with problems in which it was necessary to implement set with the ability to know ordinal number of item and also to get item by its ordinal number. That is order statistic in the set. And by ordinal number, they mean how many numbers are smaller than this given number. And to get an item by its ordinal number, they mean which is the fifth largest element or nth largest element in this set. And then I remembered that in the comments to that article, someone mentioned about the mysterious data structure order statistics tree, which supports these order statistics tree. I feel like there is some underlying thing, order statistics thing, which comes from math, which supports these two operations and which is implemented in STL, unfortunately, only for GNU C++. And here begins my fascinating acquaintance with policy-based data structures, and I want to tell you about them. Let's get started. In this article, I will talk about IMO, the most interesting of the implemented structures tree. In my opinion, shit, I thought International Math Olympiad. In my opinion, we need to include following headers. These are the headers. This is the common file, and this is the file including tree order statistic node update. So from this file, the only thing that we need is the one that we were using to update the thing, which is this tree order statistics node. That is all that we need from this one. Okay, yes, I can be used to run many random test cases by generating. I gotta go learn some SQL stuff. Okay, cool. Cool tip I found, bro. Yes, what is it? I'd like to hear. HackerRank problems are the base to all contest problems. If you have collected the completed the HackerRank, you can solve almost all questions. Ah, HackerRank problems. What do you mean? Do they have a problem sheet or something, or just do all the problems on HackerRank? I haven't used HackerRank. What should I be looking for here? I would need some help. I would need some help. Okay, they have topic wise. Shit, I guess I saw that. I saw that. Topic wise. Why am I not signed in? Okay, wait, let me hide my screen for a minute. Let me sign in. And shit, it is not. Wait, wait, wait. Login, Google. And now it is working. Okay, okay, fine. Now it is cool. Yep, it is visible. An expert in code forces told me. Okay, HackerRank is a website for coding questions, not really for CPP topics. Really not that useful if you are doing code forces anyway. Okay, let's see. Why is it still not like that? Algorithms, data structures. Solve me first. These are easy questions. Build division. Okay, these are questions. Unsolved. All of them are unsolved. I haven't solved anyone. Advanced. Topic wise. Bit manipulation. I mean, I think this argument, HackerRank problems are based to all contest problems. I think this argument could be made for any sheet that you can find on the internet. We don't really need any fancy DS. I mean, in this problem at 1500 level, I used this thing. We had to use something like this. Ordered set. And yeah, I think this argument could be made for any sheet that you find, because yeah, every sheet has some stuff, and that stuff is used everywhere. Yep, really, yeah. I mean, instead of switching from HackerRank to Code Forces, then to something else, just to stick with something and solve questions with that thing. I'm only solving these questions and nothing else. Only I'm solving CSES when I want to practice some specific topics. And this is cool. And now for this thing, the article namespace, which we will be working on, is called GNU PBDS, policy-based data structures. Earlier it was called this. Okay, now let's look at concrete structures. The tree-based container has following declaration. Okay, but before moving, this is the common file that we need, and this is the file which we need to make a tree with this thing, this container, to make a tree out of this container. So PBDS, this is the container file which has the basic container, and we can make a hash table, priority queue, tag trade, which I don't know what is, tree, and try. We can use a try, whatever that is. I do not know what a try is. I know what a tree is. What a hash policy. Does it only contain hash policies? And my theory with this is that this one has the basic container common file, which, like, yes, it literally says container. And these other files, which we say, which we see here, all of these files, they have external arguments which could be given to this template, basic template. Yeah, which could be given to this basic template and change the policy and make it work as we want it to work. Yes, we will never know correctly. Why should it be the base to all contest problems if there are so many more resources for below expert level on code force anyway? I mean, you can make the base argument for anything. Was spreading fake propaganda. Yo. Okay, so my theory is this thing. Yep, for policy-based data structures, we have to include two files. First is the associative container, which has the template for creating all the for containers that we would want. And then there are other header files, and there are other header files which have arguments, policies that we can give to the container template and make it work as we want it to work. All of these. Exactly, you nail it. Associative container header. This is the master header that provides the container templates. Think of it like include vector. But here it gives you generic container shells. 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 Container shells. It gives me a tree, a try, a hash table, etc. At this stage, you have the skeleton, but without policies, they can't really be customized. Policy headers, there are knobs you plug into those skeletons. Each header defines a family of policies for a specific type of container. Keys, you have listed exception dot header defines exceptions used inside BDS out of range. Okay, so what would happen when exception happens? The policies are in this one. Hash policy contains hashing policies, example, collision resolution, resizing strategies, okay, which we can use on these containers. CC hash table, GP, GNU-P, hash table. List update policy, policies of self-organizing list, move to front counter. Think of these as strategies for updating linked list. Like containers priority queue defines variants of heap, and heaps are fun to implement, right? We will be implementing heap in some stream. Let's use switch between binary heaps, pairing heaps and thin heaps. Okay, it has policies for heaps. Tag and traits defines tags that specify what kind of structure to use. Okay, red black tree or split, whatever split is. And tree policy, which has order statistics thing, which provides us the order facilities and try. I don't know, but how it comes together. First, you implement this and this. You first include the container template, then plug in policies from the second set. Container, this is the container tree, and inside this, I'm using all of these templates. I'm giving values to the template of tree. Here, tree is the generic type. Red black tree comes from tag and trait dot HTTP. And this one, node update statistics order node comes from tree policy.hpp. So why to think about it? So the way to think about it is that this is the container blueprint and all the other things all the other things, which are these, they have the policies which you can use on the base container. That is nice. And back to this. Okay, so we know about these two things, why we need two different things. Not why we need two different things, what these two different things include. And after closer inspection, you may find that the last two files contained in the line. After closer inspection, you may find that the last two files contained are contained in the library standard policies. Okay, I can just simply include this one instead of including these two. We can check PBDS. Inside PBDS, we have detail, and we do have detail. And inside they are using saying there is a standard policies. Standard policies. This file, and this file does for a fact include hash tables, include list update policies. Where is the container part? The container one is not included here, it seems, or maybe it is included in some way which is hard to see. Okay, and yep. And now, yep, this is the namespace that we will be working in. Now let's look at the concrete structure. The tree-based container has the following declaration. The tree-based container, because we have a lot of containers. We have container for a tree, for a try. And before moving forward, I would like to go to the washroom, and I'll be right back. Shit. And I'm back, and we can begin talking about policy-based data structures. Yes, nice. Tree-based containers. So our first include file, this one, has a bunch of things, has a bunch of containers which we can change to our specific needs from using it by giving it different policies, and those policies are included in their specific header files. And this is the basic structure for a tree, which we can just see. Where is tree? Here is tree. We have the tree structure right here, which takes a bunch of things. It takes a key type, mapped policy, comparison, key comparison functor, not a function, but a functor, and it specifies which underlying data structure to be used. We are using a red black tree here by default, and template for this, a policy for updating node invariants. That makes like just having the word invariants makes so much sense here. Yeah, what are the invariants that the node must have? experienced participants may have already noticed that if I initialize the template only the first two types, we obtain almost exact copy of the map container map. Key and mapped. Yep, key where we can shit. I guess we can actually use this to have a map of our own, a map of our very own. Let's say and inside let's include those files. Include what? Ext, pb, ds, associative container dot hpp, and yeah, nothing else. Nothing else. This much is enough. And using mp equals and also using namespace std and also using namespace GNU pbds policy based data structures, and this thing is going to be equal to tree in which the key is integer and the value is also integer. That is enough because everything else has a default value. Default. Everything else has a default value. And now if we initialize a type of this thing, our map equals new mp, or no, not even new, just mp. Yep, and we can do mp dot insert one. Wait, how would you insert in a map like this, which has set this thing? If we do just this, then this behaves like a normal set. Insert one, insert two, and not mp but out map and out map dot insert two, and if we do out map dot size and a new line, and also include IO stream, not clang but G++ policy. Nope. Shit, where did I even write that? Yep, in policy. The heck is policy 2? Policy.cpp out uh, G++ 15 policy out. Okay, that is something that maybe I gave the wrong path for the include file. PBDS AWSOC, not the whole thing, AWSOC. A stock container, and I will turn off the LSP soft container.hpp and G++ policy based container. That shouldn't have been a problem. Literally, that shouldn't be a problem. Wrong number of template arguments. One should be at least two. Yes, shit. Yes, yes, because this thing does not have a default value. That thing doesn't have a default value. Null type. Okay, that does not make sense because my phone has been hopefully charging. This is like so bad. Now it is charging. Yep, it is. Null type. Wait, what is the null type that we provided there? Null type. Just write null type. And it is in the same this space. Okay. G++ policy. Okay, now there is only one error, which is a stupid. Wait, what? What is the error now? Shit, yes. It it isn't supposed to be like this. Not Clang, what the heck? G++. Policy based. Not slash out. And we get that the size is equal to 2, which is correct. This is correct. Hello. Awesome. Shit. You saw my video for the first time when you were in your college. I guess you are the same awesome. And experienced participants may have already noticed that if initialize, there is some grammar problem in this statement, but we can parse it. Experienced participants may have already noticed that if initialize, that is tripping me off, that if initialize the template, that if we initialize the template only the first with, okay, that if we initialize the template only with the first two types, we obtain almost exact copy of the container map. Yep, just say that the container can be set. For this, you need to specify the second argument template as null type, which we did. In older versions, it is null mapped type. Here we did use to have a set, we used null type. That is cool. Just say that the container can be set using null type. By the way, tag and node update are missing in map. Let us examine them in more detail. Okay, yes. Tag, class denoting a tree structure, which we will use. There are three base classes provided in STL for this. It is arbitrary for red black trees, splay for split trees, and OV for ordered vector tree. Okay, I only know about red black trees. This and this I don't know. Sadly, and the competitions we can only use red black trees for this because splay and OV trees using linear timed split operation that prevents us to use them. Okay, okay, let's not get into what these two trees are. Node update, but we know that we can use red black trees under the hood to store our data structure. Node update. Class denoting policy for updating node invariants. This singular word, invariants, node invariants, this singular word, node invariants, this is very meaningful. This is explaining a lot of things about this thing. By default, it is set to null node update. That is additional information not stored in the vertices. In addition, C++ implemented an update policy, tree order statistics node update, which in fact carries the necessary operations. Consider them mostly like the best way to set trees is as follows. Consider them mostly like the best way to set the tree is as follows. The best way is this. Okay. These are the arguments. The first one, a set of trees which is ordered, give it integer, then null type for the key value, and then the comparison function is just less, and then the binary tree, and then tree order. I here understand what this means, what this means, what this means, what this is, and this is just the name. This is the only thing that I'm like getting a bit trippy about, and everything else makes sense. If you want to get map, but not the set, if you want to get map, and also this, yeah, a bit of this, what would this mean? And if you want to get map, but not the set, as the second argument type must be used mapped twice. Okay, maybe my English is bad. If we want to get map, but not the set, as the second argument type must be used mapped type. Okay, again, I can understand what this means. They are saying if we want to use a map here instead of a set, we have to provide some map thing here, mapped type. Apparently, the tree supports the same operations as set. At least I haven't any problem with them before. But also there are a few, there are two new features. It is find by order and order of key. The first returns an iterator to the find by order to the kth largest element counting from 0. The second returns the number of items in a set that are strictly smaller than our item. For example, use this. Yeah, that makes sense. Find by order, give it a number, and it will, if you give it a number k, then it will return the kth largest element. And order of key, if you give it a number, some k, then it will return the number of numbers which are smaller than k, strictly smaller. And one more interesting thing is using, first of all, template type name for type T, using ordered set equals tree, first is integer, then null type, then comes the comparison function, which let's say we are using greater than instead of less, and then comes the update policy, I believe. Yeah, the last thing, update policy. Oh, no, shit. Then comes red black tree, the underlying data structure. RB tree tag, red black tree tag, and then tree order statistics node update. Okay, statistics node update. That is crazy. That is crazy. Let's initiate order set sp and insert some stuff. Insert 1 and sp dot insert 37, of course. Sp dot insert guess the next the number 42. Sp dot insert the next number 137. Okay, and we have some extra operations apart from normal set, which are st dot find by order, and given 3, I will get the third largest number, which is going to be 137, because this is 0 indexed. So see out this and see out. Let's see order of key. Order of key 50. How many numbers are smaller than 50? Answer should be 3. If it does compile, G++ policy-based data structures doesn't compile. It doesn't compile G++. Okay, which G++ are we even using? That is the right one. Alias. That makes sense. That makes sense because we are using a template. So we have to say integer. We are going to store integers. Okay, maybe that was not the right thing. It might be because of the comparator function. G++, it is not because of the comparator function. Order of key. Order of key. Find by order. These are the operations, but it doesn't work somehow. Not Clang, G++. Now it does work. Now it does work. But we also want to use those functions. Dot order of key 50. See out. Yeah, just this. And does it compile? It does compile. That is cool. And when we use the other function, cout st dot find by order 2. Okay, that is where we are messing up. Find by order. Find by order. Why is find by order giving us error? Okay, because find by order returns a pointer. So we have to go to that pointer. Makes sense. One 37 and 3. That makes sense. That is actually correct. Because we did find by order 3, the third largest element beginning at index 0, which is 137. And then we did st order of key. How many elements are smaller than the key 50? We have 3 elements which are smaller than the key 50. And we can even change the order. Shit, that would be interesting. What will this return? I think out of bounds error, or maybe 37. Policy.c++, because I do not have enough elements in my thing. 0. That does not, that makes sense, but why would you use 0? What if 0 was a legitimate element? turn off the LSP. Okay, that is fine. That is fine. We can handle it. Now, beginning forward. Now, we know that this new thing provides us two extra operations: find by order and order of key. And then, finally, I would like to say about the performance of order statistics tree in STL. For this, I am provided the following table. Problem. Okay, these are problems, and these are okay. Order statistics take 0.062 milliseconds. Here it takes 200 milliseconds. Here also 200 milliseconds. Here 400 milliseconds, which is like sometimes faster, sometimes slower in this. Okay, I do not literally know. I do not know about segment trees. I will have to read up on them. Binary indexed trees, I guess B trees. The final task requires direct access to nodes of trees. Problem solution, these are problems. Stars. So this is not very cool, I guess, because this is slower than the other ones. The performance gain is okay. It is fine. It is fine. It is fine. It is fine. Sorry for my poor English. No, it is fine. As you can see from all of this, order statistics tree relatively little. Yes, you have been excused. Order statistics tree is relatively little behind handwritten structures and at times ahead of them in execution time. At the same time, the code size is reduced considerably. Yes, hence we can conclude is what we can conclude is that order statistics tree is good. It is good and it can be used in contests. That is cool because it reduces the code size that we have to write. Yep. Besides tree, I also wanted to describe here try. However, I was confused by some aspects of its implementation, greatly limiting its usefulness in programming Olympiads. So I decided not to talk about it. If anyone he is encouraged to try to learn more about this structure by himself. Useful links are these: documentation for PBDS. Okay, we have a literal documentation for PBDS on the GNU website, gcc.gnu. That is cool. And okay, okay. I guess we are not going to read this. Maybe some other thing. Shit, that is too much. And look at this. This website is created by the guy who has who changed the open source industry, Richard Stallman. I wouldn't think that he personally wrote this website, but this is the design that people like this go with. Just a basic HTML file with no JavaScript at all, bare minimum JavaScript. That is their UI expertise. That is funny. Yo, hello, welcome back. And null policy. So now what do we know? We began with saying that we need some data structure which has these properties. And now we did find a data structure which has these properties. Those data structures are inside PBDS library. This is policy based data structure. We know what data structure is, and policy are specifications that we want with our data structure. So we can define custom data structures based on some policy, and these have been divided into two things. First, we have the container, and this container can be of different types. There could be a tree container, a hash table, or a trie. These are the different containers which we can use. Containers. And all of these containers are in a single library called associative container.hpp, which is inside external pbds. Yep, this container is inside this library. And then we have some extra libraries. For example, not for example, literally, if we go here, include C++, 15, external, pbds, these are the other libraries. These libraries have so-called policies. These have policies which we can apply on these containers and make these containers do or behave in the way that we want. So that is cool. This library has the container, and these libraries have policies which we can apply on those containers. And that is cool. Okay, and the two extra operations, and today the container that we read about is a tree. And to be more specific, an ordered statistic tree or something like that. Ordered statistics tree, this one, tree order statistics node update. And this is the thing that I want to read about now. Tree order statistics. Yep, this one, whatever this is. Tree order statistics node update. Tree ordered statistics node update. So we had this data structure from our container, and we applied this policy on our container to make two operations available. And those operations are let's say ST is our data structure that we initiated with this. The operations are find by order, which takes in k some key, and st dot find, or not find, but order of key, which takes in a key k. And these two are very useful. This one gives us what is the kth largest element in our set, and this one gives us the number of elements which are smaller than the value k. That is cool. Now I want to read about this thing. Order statistics, tree order statistics node update. What does it actually do? That's enough GNU study for the day. Lol. Yep, that is quite a bit of GNU study. Are you still studying that? I feel it is not much important for now. I mean, because whenever I'm using this data structure again, I want to understand everything that I see on my screen. When I used this yesterday, this was alien language. But now I understand that this library has containers, this library has policies, and what are policies, what are containers, and why we are using this thing, GNU PBDS, what is this thing? This is the namespace in which we are defining all of these things. And the first thing that we provide is the key value. The second thing is the mapped value, then the comparator function, then the underlying data structure, which is red black tree here. Then comes the how to update the invariance. And that is all. That is all you need in the tree container. And we haven't even gotten to what tries are, the try container, and how we can use it. And there is also the hash table container. I don't know about try. I would have to read more about try to get comfortable with them. But the main point is whenever I see something like this, I do not want to use cognitive energy to understand what I am seeing. If I get familiar with them by studying about them, then that is cool. Bro, can you tell me a good resource to study in CPP? I searched for a video, but it was in JavaScript. Yes, you can use, where is it? The C++ programming language by Bjorn Stroustrup. Everything you need is right here in this language. This book was written, I guess, in 2012, and this is based on C++11 standard. This doesn't have the latest things, but the major updates were in C++11 standard, and this has most of the things that currently there are. Try was something similar to tree, but a little different properties. Yeah, something like that. Tries. You can use this book, C++ programming language, and it is long. It is a big book. Look at this. This is the book is downloading and it is taking quite long. And I do not recommend going through the whole book from start to finish. That is not humanly possible. What I would recommend is there is the introduction section in this book, which has 5 chapters, and you can go through them and you would get a very nice understanding of how things are. Wait, no, this is not the latest one. This is old. This is from 1997. Shit, this one is old. 4th edition. Okay, let me open my local copy and let me hide my screen for a minute. I have the book downloaded. Where I forgot. Yep, I have it now. Cool. Yep, this is the book, and you can download it from some website shortly. And continuous scroll. If you go to the index, see this book is long. This book is long. If you go to the index, you will see that there is the introductory material, and you can go through these 5 chapters, and these 5 chapters have a lot of things, and this is very dense. I would say reading these 5 chapters is very dense, because there are a lot of things that you have never heard of in these 5 chapters. And I would even say you don't even have to go through the last chapter, because it uses mutexes, and it is, yeah, it uses mutexes and multi-threaded programming. This is cool. This is what I use for my reference whenever I want to read about something in C++. And currently I'm reading about templates, what templates are, because I was struggling with templates in earlier history. Is there a video also you can recommend? Okay, video. Don't really watch videos, but if you want videos on specific topics, I guess you can just search C++ allocators templates. See, allocators. I was reading about allocators, and this guy is cool. This I watched this videos. Yeah, you can just go and look for some video. Erecto, good. Erecto. There is. mm, this guy. This guy is also nice. You can watch his videos. You can watch this guy's videos, and I wouldn't recommend watching some Indian YouTubers video, me included. Shit, me included, because the mindset that I get from watching those videos, it is like I'm in school and this guy is teaching me something because I want to get a job. but I don't like that mindset. So you can watch this video. You can just search C++ on whatever topic you want to watch a video about and watch a video. Yes. And now this thing. I want to read about this thing. This one. I get how the other ones are used, but what does this policy mean? Yep, you're welcome. I mean, thanks. Thank you. What is this? Good. You have zoned in one that looks like dark magic. This policy is what gives PBDS tree its order statistic. Okay, what does this thing even mean? Order statistics before moving forward. This mean order. Let me zoom in. Statistics. Is it a computer science concept or a mathematical concept or something natively matched but adopted into CS? What is it? Let's untangle. In mathematics, statistics and probability, that is what we have. In statistics, the order of statistics, of a sample are just the sorted values. If you look at if you take a sample of n random variables, xn to xn, and sort them according to some operator, less than equal to, according to some operator, then xk is the kth order statistic. Statistic isn't okay, I'm not getting this. Why are we calling a individual element in this thing a statistic? Statistic is supposed to be, isn't that a concept, a method, statistical method? Order statistics are a native mathematical strategical concept. In statistics, order statistics. Okay, why is this tripping me off? The order statistics of a sample are just the sorted values, the order statistics. Okay, I do get order, but statistics. It's just why are we using this statistics here? If you take a sample of n random values, all of these, sort them, okay, then xk is the kth order statistic. Does that make sense? It is the kth order statistic. X1, the minimum, xn, the maximum, and the middle one is the median. Order statistics are natively in computer science, data structures, algorithms. Computer science adopted the term because many problems boil down to finding the kth smallest element or what is the rank of this element. Quick selection algorithm finds the kth order statistics. Okay. I do not like them using this term order statistics like this, as if it is very obvious for anyone to understand. Order statistics. You are here referring to a element in your set by this term. Statistics. Statistic is the term statistic used to refer to elements in a sample data. Okay, what does statistic mean in math? In statistics, a statistic is any function of your data. If you have these, the mean is a statistic. Okay, raw data, and we applied some function on that raw data, and what we get after applying that function is a statistic. Shit. Okay, now it feels very obvious if my understanding is correct. Even the maximum is a statistic. Yes, shit. Given a raw data, you find its statistic. Statistic is some useful information that you got after applying your operation. So the word statistic does not mean the whole data set. It is a summary number or function computed from the graph, computed from the sample. Summary number or function. Okay. What is an order statistic? Then we are finding a statistic which has order. Take your sample, this, sort it, this. Each sorted element. This is the order statistic. Okay, it can give a summary number or a summary function. And here, whenever we give a value k to that summary function of order statistic, we get the kth largest element. Each sorted element xk, wait, my laptop is going to die, but that is fine. I can save its life in a while. Each sorted element xk is called kth order statistic. That makes sense. That is not very intuitive, but that is making sense now. That has started to make sense. Why? Because, wait a minute. Yep. Why? Because it is a statistic, a function of the sample. Specifically give me the kth smallest. And it depends on the order of the data. So in statistics, first order statistic. Statistic. Statistic is the term used to refer to a summary of our basic raw data, and we get that when we apply some function, some operator on our data, and this statistic could be a single number defining our whole raw data, or could be a function that gives specific statistic for some input value. In our example, we are fine. We have a statistic function which takes in a number num number and which takes in number k and returns the kth largest number in the data. Okay, that is true. And this is called order statistic. Okay, now I got the spelling right. It is called ordered statistic because called kth order statistic. It is called kth order statistic. Kth order statistic. Why is it called kth order statistic? Because we are finding the kth, because first of all, this is a statistic about our raw data. First of all, that is why we are referring to it by the term statistic. And this statistic statistic has to do with order of our raw data elements. Second of all, hence the term order, and we want this order statistic for the key element, hence the full term key order statistic. I think that is cool. I think that makes sense. Kth order statistic. You have pierced statistic in general. A statistic is any function of the sample data. It could be a single summary number, mean, value, min, max, etc., or something more structured like a function. Example, an empirical cumulative distribution function. Okay, so you are given a statistic. A. So you're right. A statistic is derived from raw data by applying some rule operator. Order a statistic specifically. Take a data set like this, sort it into ascending order this. Define the function this, which returns the kth smallest element. Or you could, yeah, it does return the kth smallest and not the kth largest element. This fk, fk, this fk is an order statistic function. For a fixed k, the value xk is called the kth order statistic. Why the name makes sense. It is a statistic because it summarizes the data. It is an order statistic because the statistic depends on the order of the sample, and when you specify k, you are pointing to which element of the order you want. So this is called kth order statistic. K is different and order statistic is different. Kth order statistic. Your intuition is spot on. The kth order statistic literally means the statistic that summarizes the data set by giving the kth element in the sorted order. That is why in computer science, PBDS, policy-based data structures, order statistics trees, the phrase was borrowed directly. We want exactly that function accessing the kth or smallest element. Okay. Now we know what order statistic means, and we can go back to our thing. This thing. I get now how the other ones are used. Yep. What does this thing mean? Tree, its order statistic superpowers. Now this thing makes so much more sense since I know what order statistic is. That is very cool. And what it is, normally a balanced binary search tree, balanced version of the binary search tree, BST, like a red black tree, just stores keys and ensures they are ordered. But if you want to ask questions like what is the kth smallest element, how many elements are strictly less than x, the plain tree has no idea. It only knows how to insert, delete, and search. It only knows how to insert, delete, and search. Yes, but to answer those questions, every node needs to carry extra metadata, namely the size of its subtree. That way, if the left subtree has size s and you are looking for the kth element, if k equals s plus 1, the current node is the answer. Shit, okay, so that is the metadata that they need, only that, subtree. And if that is the case, then every time when we call those extra functions, the functions like this, find by order and order of key, these functions also take log n time because they are going through the tree. If the left tree has size this, then yeah, cool. Okay, what the policy does. The PBDS library leaves the job of what extra data needs, extra data each node stores and how to maintain it to a node update policy. That is what this is. Okay. The PBDS policy-based library, data structure library, leaves the job of what extra data node stores and how to maintain it to a node update policy. Okay, they have outsourced the policy. That's what this thing is. It augments each node with subtree size info. It automatically updates this info on insertion, deletion, rotations. Mhm. It then exposes two new methods. These two, find by order and order of key. So the policy is essentially keep track of subtree size so we can answer rank plus select queries. Why it's a policy? Because not every tree wants or needs this overhead. If you don't care about ranks, you don't use it, you save memory time. If you do, you plug this policy and suddenly your tree behaves like an order statistic tree. And this is the example. That is cool. That is cool. And now that we are armed with that knowledge, let's solve a question which uses this. And literally, we can solve the question that I was struggling with before. Competitive programming. Start new vim and yep, stop the LSP. And apart from this, I will be needing include ext/pb policy based data structures slash associative container.hpp and include ext pb I messed up above. This is supposed to be and tree or order tree. Okay, shit, I forgot what the actual header is supposed to be. We can look it up. Tree policy. Okay. Tree policy. This is called tree policy. And yep, using this and using namespace GNOME pb ds. I don't know if there is a space or not. And then template type name t using ordered tree. Okay, we will rename it to something else. Order tree. Very intuitive, very original. No, rank tree. Let's call it rank tree. Rank tree equals tree storing type T null type for the second, like mapped type. And then third is the comparator function of type T. And then we have red black tree tag. And then we have the main thing which we are using from tree policy, which is order statistic tree something. Tree order statistics node update. Okay, I think I can remember that. Tree, what was it? Let me order statistics node update. Node update. And yep, that is enough. And in here, what were the things that we have to take in? How is the input given to us? Input is given like that. Okay, int n, c in n, and vector of not integer but parent a size n, and for auto reference, yep, reference I j in a, c in j, and then I, so that the ending place ends up in the first place of this vector. And then we will sort it, sort a dot begin and a dot end. And after sorting, what do? We initialize our rank tree, st. Let's call it tt. No, name. What name do I give it? Rank. And for auto reference I comma j in a, what we have to do is we have to find the answer. Long response initially is 0, and we will have response plus equals rank dot size minus rank dot order of t j. J is the starting point, and rank dot inserts j. Out rest, and we will not even check this locally. The only thing I think might be wrong is this namespace. Let me just check that. The namespace. Yep, that is wrong. So we don't need a space. This is the correct thing, and I won't even check this locally. I will directly submit this. Let's do that and see if it works. It would be cool if it does work. Let's go. Compilation error, at least I do not want a compilation error. Okay, so I messed up somewhere. I'm not using my LSP, that is the problem. Sort, rank, tree rank, yep, res for reference in A, yes, res plus equals s dot size minus rank order of key j. So what is the problem? Let's see. Okay, this thing I got this wrong. Tree order statistics node update. Got the name wrong. Tree order statistics node update. pre-order STAs TICS status regard pre ORDER order statistics node update, and I'll submit it directly without checking if it is correct or not locally. And that would be cool if it works. And if I get a compilation error, that would not be cool. Running. It is not even compiling, it is running, literally. I hope it works. Okay, it just keeps on running. It keeps on running. Deduction. Code forces is slow. It is running now. It is running. And not just running. It is correct. The mistake was this thing. Since I'm using a template, I have to specify what I want. And since I do not want to get this wrong in the middle of a contest, I will create a different snippet for this. Accepted. I can create a different snippet for this, and let's actually do that. pb pbds.cpp and paste this, and not just this template, type name T, and using rank. Okay, let's just go with the convention. Order set, order set, or ordered set. What is the conventional name that they use? Ordered set. Stop the LSP. Yep. And now ordered set equals tree, type in T, null null type, and the third one is less for type T, and then red black free tag, and then free order statistics. Okay, my laptop is going to die, but that is fine. I can put it on charge. Tree order statistics. Node update. And do I need something else? Nope, I don't. Shit. We would need at some point, maybe not just a set, but a multi-set. And the only difference is in the less function. Less than and equal to. And that is all that we would need. Snippets.lua, and we can go down and paste, and here for the whole thing we can say, instead of abs sum, substitute, abs, sum, write, pbds globally. So file path, pbds find path for cp pbds boilerplate, and then read it all, and yep, change this leader pbd. No, I will mess this up. So I will write a function instead of a key map. How do I write a function? Vim API Vim dot API dot and Vim create user command. Yep. And the name is pbds. That is going to be the name of our command. And function, right? What are the three arguments that are required? The function and options. Options are empty. Okay, and what is the function? Function is vim dot API dot nvim put lines. Lines are vim dot split blp pb pbds. Yep, split this on new line character, and we have to provide, due to some reason, C and then true twice, and the options are going to be description, puts code for policy based data structures. I think that is cool, and that should work. And here, if I remove all of this and then I say pbds in the command line, I get the things. And if I run this, it does work. So that is cool. It does work. It does work. It is working. It is fine. And we have done quite a bit in this stream. I didn't knew what any of this means, but now I know what this means, and that is pretty cool. And now I had to only give it about 3 hours of my time, and now I know this for eternity. So that is pretty productive. And that would be the end of today's stream. And thank you for being here. Bye. Really appreciate it. Bye.